Yes. Well, no, here directly I'll go here only. So we have one concept called semaphore. Before semaphore, let us understand why we want to go for semaphore. Okay, we have a simple code here, very simple code. I'm taking module and module. Okay, and I didn't take any class, just module and module I'm taking here. Uh, Module and module I have taken. I have written one task. You can call it as method or you can call it as task, your wish. Okay, so I have written one task, I have written another task. Two tasks are there. Okay, na here the delay that I have given is 5 nanosecond, here the delay that I have given is 4 nanoseconds. Okay, na so it is written inside the module. Two task is written inside the module. Now inside the fork join, you know how fork join works, correct? Fork join works parallelly, means both the methods are executing parallelly, correct? No, so parallelly when it is executing, say it is 5 nanoseconds, it is 4 nanoseconds. At that particular time only it will get executed, correct? No, so I'll run the code according to what delay you have given. According to that, first I'll get see at 0 nanoseconds I'll get this to in outputs. After 4 nanoseconds I will get this output. See, read completed from memory. After 5 nanoseconds I will get write completed from the memory. According to our whatever the content I have written, I got the proper output. No problem here. But the problem comes when, even though I am writing fork join, I want first to this particular task to get completed rather than completing this task. How it is possible? See, if that is the case, I should change the delay na. Means at less delay I should write here and more delay I should write here, correct? No, but no, in the industry that is not the scenario. Some people, some other colleague will be writing some other file, you will be writing some other file. Okay, so the synchronization with respect to the files is not developed so easily. Okay, so the delays will be this only, it will be 5 nanoseconds only, it will be 4 nanoseconds only. But the fork, inside the fork join, whenever you're trying to call the methods na, those methods should be it is working in parallel. That also I can't change, and the delays also I can't change. But my agenda is, I want first to get this output, then only I want to get this output. How can I do that? Means with the help of semaphore. Means you should not disturb the code. Without even disturbing the code, you want to achieve your specification. Okay, you should not touch the delays, you should not even touch the fork join concept. Still you are supposed to complete. See, there is nothing will happen even if you write above and below also. You don't expect that read memory will complete first. No, if you run, see, still same output only you will get, because we know that inside the fork join parallel execution will happen. Okay, just by writing read memory above and write memory below, you will not get a proper output. See, here also write is completing last, first read is happening, then only write is happening. Okay, but my requirement is first write should get completed, then only read should get completed. If that is the case, I should go for semaphore. In the semaphore, what happens, I will be having a control of my code. Okay, so which one to execute first, which one to execute second, irrespective of whatever the delays you are giving, irrespective of whatever the task you are using, irrespective of anything, you will be able to control the code with the help of semaphore. Okay, so in the semaphore we are having some concept like keys concept. Keys. Okay, I will tell that lot many examples are there, one by one we will discuss. Okay, so that keys concept I will tell. How to declare the semaphore, keyword semaphore, name of the semaphore, that is user defined name, and I'm creating a memory. See, as I told, wherever, whichever the concept you people want to create a memory, we will be creating a memory using a new constructor, correct? Yes, Knaneshwar, any doubts? Okay, okay, we will be creating the memory using the new constructor, there is no doubt in that. Okay, but here I'm writing something called one. What is this one? Means I am creating one key. Okay, or else you can tell that I am initializing one key. Okay, in the memory I am having one key. Okay, na, that key who is getting first, write memory is getting. Okay, now the key means get is usually the blocking method. Get is one of the inbuilt method of the semaphore. Okay, and it is a blocking method, so the key is present here now. Okay, so now remove here, the key is present here. Okay, now irrespective. See, I know that inside the fork join both will get executed parallelly. Now also both is executing parallelly only, but with the help of semaphore I am trying to control my method. Now first line number 6, the key is present here na. First these two statements will get executed. Afterwards you should put back the key. Okay, you should put back. You have got the key na, you should complete your work. See, it's like if I draw the diagram. Here what happens is, one second. 1 minute, it got switched off, just a moment. Huh. So here in the memory I have created one key. Okay, so this task is getting the key. Here nothing is present, the key is now present here. Okay, these two statements will get executed. Once after executing, I have to put back the key again. The key should be available here, then only the other task can come and get the key again. The another task is coming, it is again getting the key is present here. Again the statements will get executed. Again I have to put back the key in the container. This is how we are supposed to get and we are supposed to put back the keys. Okay, so this is like one master is there, one two slaves are there. Okay, both the slaves want to do the communication with the same master, but according to the rule of system verilog or according to the rule of the programming languages, any programming language you take or any protocol you take, it's like one master can communicate with only one slave at a time. You can't do multiple communication. Okay, in that case what happens, we are going to create one key na, with the whoever is having the key, whichever slave is having the key, that slave will come, it will get the key, it will do the operation, it will put back the key. Suppose if you do not put back the key, then other slave, how it will do the communication? Key is like a token. Like if you want a doctor's appointment, you will take a token, like, or you will take an appointment the same way. Okay, if you don't give the token back, again the other patient, how they will come and how they will get the card, that particular token, right? The same way it is. Okay, you have, once you get the key, you also have to put back the key. Okay, and this get and put method is a blocking method. Okay, using non-block, you have a try get method, but it's of your no use. Okay, try get is anyways not utilized in industry also, but yeah, there is also existence of a non-blocking method, that is try get method. But when you use try get method, again there is no use. Means if the try in the try get method, what happens, the key whatever you are getting, no, it will not get blocked here, it will be available to the other task also. Then again what is the use? Getting my point? Okay, so that is not utilized application wise. Okay, but application wise what is utilized means, the blocking methods of get and put is only utilized. Okay, but try get method if you use also, it's of no use, because your parallel execution will happen na. If you use try get method, it is non-blocking, which means what, key won't be blocked here. The key will be available for this task also, key will be available for this task also. Again that is again the parallel execution, again it is of no use. Okay, so now if I run the code, what is this, 1 second, just a minute. 1 second. Okay, okay, so when I run this code now, Okay, so if without the semaphore I was not able to control my code, now I am able to control my code. Okay, so okay, see first what is happening here again, read write is getting completed first. See, first write is beginning, write is getting completed, then only read operation is happening. Okay na, see ma'am, then why are, what is the use of now fork join? See, now if for example in the previous code, see, fork join I can't control because some of my other colleague has written the fork join. I can't go and change his code because only he can change his code. Okay, he has written fork join. I can't tell him, man, here I want first write method to get executed, then read method to get executed. So please remove that. What? No, the fork join. I can't tell to him. Okay, without disturbing my code, I want to control. See, suppose if I remove that fork join, I am able to get my requirement. Means first operation is getting executed, then only read operation is getting executed, means one after the other. Means in the initial begin and if you write, what happens, one after the other only the things are getting executed, correct na? Then I can tell my other colleague to remove fork join, but I can't tell him because he might have written for some other application according to his code requirement. He has written the code, I can't disturb his code. Without disturbing his code, I want to achieve my requirement, then only semaphore comes into existence. Okay na? Yes, if I remove that fork join, it will, what is my requirement, that will happen, but I can't remove that fork join. That is how it is. Okay, other code I can't go and disturb, but still I should get my requirement, means then I can go for this particular method. Okay, so as I told, try get we won't use, but still I will show you what happens. Try get is a non-blocking method. Okay na? So I'm using semaphore again, one key. You can use multiple keys. That multiple keys concept of also I will tell now. Don't worry. Okay. So I'm using the try get method. Okay. Here also I'm using try get. Here also I'm using try get. Here what happens? It is of no use. Means usually again parallel execution only will happen. I'll show the output because the key is not getting blocked here. Okay, and one more thing, you only have try get, you don't have try put. Okay, three methods are there: get, put, try get. Get and put are blocking method, try get is a non-blocking method. Okay na? Semaphore is declared, one key is declared. See here according again same parallel execution only will happen, no no changes. So this one key received. Okay na? Next what? Okay, process started. Okay na? See, actually I should get process I completed, correct na? But I'm not getting that. Again the key is going to the some other task. That is what, diversion should not happen. If I use get method will take care all the statements of the task one should get completed, then only it will go out. Okay, means if I put, it will go out, but the try get method is not like that. See here, only still two statements I completed: first statement, second statement. Third statement is not completed, again I'm getting the other output. And this should not happen actually. That is why try get is not used, but still for your example I have kept one no code. Okay now, three methods are there, but application wise we are using get and put for the proper application wise. Okay, can I use, can I create a multiple keys? Yes. So here you can see one minute. Ah, I am using, sorry, I am creating three keys. I am initializing three keys. Okay, now three keys is initialized. I will be able to, can I get less keys? You can get less keys, but that is not appropriate. What happens, you know? Okay, so just imagine I will get, I have created three keys. Okay, now see what happens is, okay, so here I have created three keys I have created. Okay, so if suppose just imagine you are just getting what, two keys, you will get two keys for some of the task. Still how many keys is remaining here? One key is remaining, correct now? Some other task can come and take that key, again your concept is disturbed, correct now? So always it is recommended to take how many keys are available in the container, take all those keys. If you take only one key, what happens, another two keys are present in the container, some other task can come and again take those two keys, and also this also do the communication, you also do the communication, again the same problem occurs. Okay, so always in the semaphore concept is recommended, it is recommended for you people to take whatever the keys are declared here, no, try to take all those keys. Okay, so you should take three keys. Okay, you will be able to print these two statements. Okay, it will print. After that, when you are putting back, actually you have taken three keys. You have done your work. Okay, work is done, communication is done. While putting back the key, can you increase the keys and can you put back? Yes, actually you have taken three keys, but you are putting back five keys. Is it possible? Yes, definitely it is possible. But disclaimer, you should not put back less number of keys. Means you have taken three keys. Now you can put back three keys, or you can put back more number of keys. Both are okay, but you should not put back less number of keys. Two keys and one keys you should not put back, because if you do that, okay, just imagine you have taken three. Okay, you are putting back only one key. Okay, okay, one key you will put back. How many keys are remaining with the task? With the task, still two keys are remaining, correct na? Some other task will come and use this one key. Okay na? Again the same problem. This task is having two keys with it, which is again doing the communication with the master. Another task is also having another key, which is also doing the communication with the master. Again same problem. Okay, so what I recommend is, the proper procedure is, okay, we will create three keys. Always take how many keys are available. All the keys you should take. When you are putting back, it's your choice. Put exactly three keys or put more number of keys. Both the options are fine. Next time, another task, when you are using, no, for example, you are putting back 10 keys. Just imagine. Now in the container, 10 keys are present. Okay, na? Next task, next task, when you are getting, now get all the 10 keys, and when you are putting back, put back all the 10 keys, or else put back more than 10 keys. That's your wish. But less you should not put, and less you should not take also. Don't take less, don't give less. Simple. Okay, so this is one rule that you have to remember. So whatever the keys you people have created, more than that you can put back. Okay, so if I run the code, I have taken three keys, but I'm putting back five keys. That's fine. Whatever it is, process is started, process is completed. I'll get that output. Okay, see, process is started, process is completed. Process started, process completed. Okay, na? Yes. Yes, Muhammad.
Yeah, ma'am, I have it out. We are controlling according to the fork join, right?
Here, fortune is not utilized na.
No, no, not in this. The previous example for
Ah,
semaphore.
okay. But here there is no
How we are
importance of fork join, na. Again, according to what I require, according to that I'm controlling. No, see, some other colleague has written fork join because he wants the code to get executed parallelly. But if I execute parallelly, my requirement is not getting fulfilled. So according to my requirement, I am controlling the code, using controlling the task basically using the semaphore.
right, right.
Uh,
Not this also. Like above when I was saying,
mm,
how we are able to control the two different tasks. First, the right should execute, then it should execute.
mm,
So whatever task we are calling first, it is executing the write mem first,
mm.
then it is executing the read mem first, right?
Yes, yes.
Okay, okay, that was nice.
Suppose you see, if you do not want semaphore, simple point you can do, you can simply remove fork join. Okay, if you remove fork join also, what is your requirement? First write task you want to complete, write task will get completed, then only read task will get completed. You can do that, but you actually can't do that in the industry, because that one particular code is handled by someone else. You can't go and tell them to remove the fork join. Okay, fork join should be there,
Yes.
but you want to execute sequentially. In that case, you can go for semaphore. That's how it is.
Okay, okay,
Huh.
got it.
Okay, fork join will be there, but fork join is executed sequentially, means with the help of
Sequential.
semaphore. Huh. And sometimes I
Yes.
can't even tell sequentially, because what happens is, suppose if you take multiple tasks, then it is not even sequential. Then what happens is, suppose you have another task you have, you think, write mem something, another task you are having, you think, copy. Okay, read mem something. Okay, some four tasks you are having. So here you have written again the same thing, four tasks you are calling. Okay, read mem rem Right. Ma'am. So four tasks you are calling, but the point is in the semaphore, I don't want them to execute sequentially, but I only want that read memory should get executed first. Then I want this one to get executed second. Then I want this one to get executed third. I want this one to get executed fourth. Now what happens? Again, I can't go and change all the delays, right? Then again, with the help of semaphore, I can first write read memory task here. Read memory task, I can write it first. Okay, so first this particular task will get executed. Next, read mem. Okay, so this read mem I can cut it and can post it here, so that after this particular task will get executed. And next, read mem third, and then comes fourth. Like this I can arrange the task, and with the help of the keys will get and put, get and put, get and put, and get and put according like this. But I can because if even if I remove fork join, okay, again I can't rearrange. Just imagine you have 25 tasks. How can you rearrange 25 tasks? That is not possible. So with the help of semaphore, easily I can use get and put method, and I can rearrange the task to get executed in this particular order. Okay, sometimes even if you remove fourth join also, problem won't get solved, because my requirement is not even sequential this time. My requirement is again random. First one, second, third, and fourth. For this requirement, even if I remove fourth join also, my requirement is not fulfilled. But with the help of semaphore, it is fulfilled. Got it, no?
Okay, okay, okay.
Yes.
What I thought is like previously in that initial begin function we are calling now.
uh,
Inside that, according to that line number like 46 or 47,
uh.
whatever task we are calling first, it will execute first. That I thought first.
No, that is only that is how it is. But I see here, here what is there now? Here fork join is there. Here fork join is
Yes.
there. Okay, so I
Hmm.
am not controlling this. I am controlling this part. Okay, so here how
Okay,
I am
okay.
arranging, how I am arranging the task according to that, that get and put will execute. Okay, it's that is what
Okay,
I
okay,
told
okay.
also. Even if that is what I told also, even if you write this above and below
Hmm,
also,
hmm,
means it will not work.
hmm.
Right, so
Okay, okay, okay.
that's what, even if you
Yes.
rearrange it won't
Understood.
work. Here you have to rearrange. Okay.
Okay, okay, ma'am. Got it. Okay.
Yes,
Yeah.
yes.
Thank you.
Mm-hmm. Okay, so putting back more number of keys, that's fine. Here. So the mistakes what all you will commit is when you are putting back more, getting and putting more number of keys there. Here, module and module. Okay, first three keys I'm getting. Okay, let me take a diagram for this. So this you people have to again execute it. Okay, so next week one doubt clarification session I will give. Okay, so please make use of a proper time. If you want till 31st, I will drag the classes, no problem, but I want everyone to please practice these codes. Okay, because just listening in the live session is not enough. Okay. Okay, so here three keys I have created. Okay, so here I'm getting three keys. Okay, here it is empty. Okay, I'm putting back five keys. Okay, which means again five keys I've got. Okay, next task. Okay, these two output I will get. First output, second output. Next, I am five keys are present now. So as I told, how many keys are present? Get all the keys. Again, nothing is present here. You will execute the task. Put back five keys. Okay, exactly five keys I am putting back. Okay, so third output, fourth output. I got it. Next, I am actually, how many keys are present here? Five keys are present. But how many keys I am trying to get? I am trying to get six keys. How it is possible? It is not possible. Okay, see, I have only five keys. You should get only five keys. If you're trying to get six keys, that is not possible. And this particular task will not get executed at all. Okay, so according to my prediction, now I should get only four outputs. Okay, so how many keys are there? Those many keys only you can get it. Okay, so if I run the code now, okay, only four output I will get. Another two outputs I will not get. See, process A started, completed. Process B started, completed. As I'm trying to get more number of keys here, which is actually not present with me. Okay, currently here five keys are present. Okay, now I'm trying to get six keys. It is not possible for me to get. So this complete task itself is not executed. Now, I will also interchange Muhammad's doubt here. I will interchange this. Okay, so now I am writing process C at last, process B first, process A second. Okay, still I will get the same output. Means by interchanging here, no difference will be there. Okay, see. Okay, my control is in this side. Okay, this is someone has written. I don't know who has written. My other colleague has written. Okay, so even if I change process C first, no. Okay, okay, if I try to get five, okay, five keys are present, five keys only I will get, which means what? Now I will get six outputs, but I will get six outputs in this order. Means I don't care about this order now. Okay, so first this output, second this output, third this output, irrespective of whatever the things I have called here. Here I have called first C should get executed, but C will not get executed according to the task in the line number 6. I am getting it first. No, first according to this order only I will get the output. So if I run the code, irrespective of whatever the order I follow here, above whatever I have written C, that I will get. A, C, B. 1 minute. C, okay, 5, 5. Okay, A, I'm getting first. Okay, so that's how it is. And here, CB, it is getting interchanged because same number of keys are there. So that is again secondary. Okay, that is, means if I give some, I will put back 7 keys, 7 keys, 8 keys. Okay, now if I run, 5, 5. Okay, C. Okay, A, B, C. See, I'm trying to control with the help of keys. Okay, first I am controlling this one. I got 5 keys. 5 keys I'm getting it, and 7 keys I'm throwing back. Now 7 keys are present. Okay, 7 keys I'm getting, 7 keys I'm 8 keys I'm throwing back. So in this case, see the order. First A is getting completed, B is getting completed, C is getting completed in a proper order. I have controlled only with the help of keys. I didn't touch below. Below, if you see, first I should get C, then I should get B, then I should get A. But according to what I have written here, that answer I am getting, which means what? My control is with the help of semaphore. Okay, if I want to control using this, I should remove fork join or something I should do here. Okay, this one is not considered at all because this code is written by someone else. I am my requirement and my control is over this particular part. That's how it is. Okay, yes.
Yes, ma'am. Okay. Thanks.
Still what else? This one, the you will get an error. Means I don't know not to use. Don't give less, don't take less. That rule you have to follow here. See, I'm getting three keys. Three keys are present. I'm getting three keys. I'm putting back three keys. Now, how many keys are present? Three keys are present. No, I should take all the three keys. Okay, but I'm taking two keys. Will that affect? Yes, definitely it will affect because the one key which is present with the code can be utilized again by someone else. Okay, see here. Okay, you are getting the output, but if you are taking some other task, one more task if you take, it will affect. Okay, according to what I have written, I'm getting it. Even if you take less number of keys also, it will work, but one key is still present here. Okay, that key, it can go again to this particular task. Again you may get this output only. Okay, so that problem will happen. So always remember, how many keys are present, take all those keys. While putting back, put back all the keys. If possible, put back more number of keys also, no problem, but don't take less keys, don't give back less keys. That's the rule. Okay, yes. So well, I'll stop here. Okay, because anyways 5:30 we are having a session, then casting I will explain. Okay, because it takes lot of time. Okay, around 40 minutes or 30 minutes I need to explain casting concept. Okay.